Okay, hello everyone. We are from Group 2, consists of Shagova, Rafiani, Tisa Shakira, and Ayas Dilan. And today we are going to presentate about the application of physics electricity, which in this chapter we pick magnetic field on Shinkansen train. Next. So this is for our content for today. Firstly, background, secondly, how it works, and then 3 conclusion. Next. Okay, first for the background. So what is Chuo Shinkansen? Okay, so Chuo Shinkansen or Tokaido Shinkansen bypass is a Japanese maglev line under construction between Tokyo and Nagoya. You might see what is maglev. Maglev is magnetic levitation, which in this case is a system of train transportation that uses 2 sets of magnets. Chuo Shinkansen itself is expected to connect Tokyo and Nagoya in 40 minutes, and this reduced time travel up to 50%. And then who is the developer? Well, the developer of this technology is Central Japan Railway Company, or GR Central, which have been funded for around like 52 billion US dollar. And the purpose of this project is to aid economic growth and development, also allow people to spend more time at their destination. Next.
Okay, so here are the timeline of Shinkansen. So first of all, the basic plan is decided in November 1973, and for the research and reports on 1919 is the research for topographical and geological research, and for the research on the residual for items was held in 2008. And next, for the Transport Policy Council was consulted on February 24, 2010 and reported on May 12, 2011. And designation of operator and constructor was consented on May 18, 2011 and designated on May 20, 2011. And for the development plan was agreed on May 23, 2011 and decided on May 26, 2011. And the instruction to construct was instructed on May 27, 2011. And for the construction and implementation plan of Shinkansen was submitted on August 26, 2014 and approved on October 17, 2014. And after that, Shinkansen was started constructed. Next.
Okay, for our next is how Chuo Shinkansen works. Okay, so Chuo Shinkansen use technology SU maglev technology, or as we all know as superconducting magnetic levitation. GR Central has been working on the development of this technology since 1987. And since then, they believe this technology is applicable for Chuo Shinkansen. SE maglev is a contactless system using magnetic levitation force generated between the train superconducting magnets and ground coils. The benefits of using this technology is to enable stable ultra high speed operation at 500 kilometers per hour, and they have better acceleration and deceleration performance. Also, SE maglev produce less carbon dioxide emission, which are environmental friendly. Next is the superconductivity and linear motors. Superconductivity is the phenomenon when electrical resistance of a certain materials approaches zero at certain temperature. When electrical current is applied to a superconducting coil, the current flows continuously indefinitely, thus creating a very large magnetic field. in SC maglev, they use niobium titanium alloy with the temperature minus 269 degrees Celsius to achieve the superconductive state. The implementation of superconductivity in ST maglev takes shape of a linear motor, different from the conventional motors used on other trains. As you can see in this diagram is the shape of the linear motors used.
Okay, so there are three systems that build the Chuo Shinkansen. The first one is the propulsion system. It is the current passing through the ground, which generates a magnetic field which propels the vehicle forward by attraction of opposite poles. The repulsion poles acting between the ground coils and the superconducting magnets built into the vehicles. Next. The second one is the levitation system. The levitation and guidance coils are installed on both sides of the guideways rails. When the superconducting magnets on the train pass through these coils at high speed, an electric current is induced in the levitation and guidance coils. This causes them to become electromagnets with forces that both push and pull up the vehicle due to the repulsion and attraction of magnet poles. Next. Okay, and then the third one is the guidance system. It keeps the vehicles in the center of the guideway at all times. How does it do that? It exerts attraction on the far side of the vehicle and exert repulsion on the near side if the vehicle moves off center. Next. Okay, so next is the conclusion.
So Leslie, for the conclusion, up to the design speed of wheel rail systems, there are slight advantages in terms of energy consumption for the Trans-Rapid maglev. From the perspective of energy consumption, under the consideration to reduce travel time, high-speed maglev systems represent a promising option for new railway projects. However, a project-specific system decision must be based on a complete life cycle cost analysis, including investment costs. Okay, so next, moving on to the reference. Okay, I think that's all from us. Thank you for your attention.